Howdy, calculates. Sorry it's so late, guys. Okay, so there's a typo on this very first thing. Make sure that you add that little tick mark so that it's prime. So, first 3 chapters we've spent figuring out how to take the derivative. Now we're going to go backwards. So if I know the derivative and I want to get back to the original function, we're going to call it f. I got to figure out a plan for doing that. Now, on this simple one, you probably would have figured out that any of these, and if you think about it for a second and you take the derivative of any of these, that they all give me 4x cubed. So what I've just figured out is that for that original function, it's going to be x to the 4th plus something. I mean, it could be plus 0, right? Or any of those. So to make sure that I'm guessing your right function, I could put plus c, c of course being a constant. Actually, we will write that down here. We're going to call c the constant of integration. And collectively, all of these solutions are known as differential equations because they come from the derivative. So they have a fancy name. We sound really smart when we say differential equations. As a matter of fact, when you go to college, if you take more math, want to be an astronaut or an engineer or a mathematician, you'll spend a whole class doing differential equations. And again, I can come up with several differential equations, and they all have the same derivative, 4x cubed. So, the operation of finding all of these solutions is called anti-differentiation. Now we sound super smart. Or indefinite integration. Okay, so make sure you get those fancy words down. Practice those on your parents a couple of times. I'm sure they're just going to go, whatever you said, honey. Anti-differentiation or indefinite integration. Tell your parents that's what you're learning at school. So some new terms within this little expression. I have the integrand. So that's the expression that I'm trying to find the original function to. So there's my integrand. And then the dx, that's my variable of integration. Might not always be x, but you know, we work with that a lot. And then of course that c at the end is the constant of integration. And then, to top that all off, we read this as the antiderivative of f with respect to x, or, just to make it more confusing, we could replace the word antiderivative with integral. So lots of times we'll call it the integral because this symbol in front, this crazy looking musical S or something or other, I write it like that, is the integral symbol. So some rules that you'll have to remember. If I take the integral of 0, it's just some constant. And so think about these and how they're going backwards. Obviously, if I take the derivative of a constant, I end up with 0, so that makes sense going backwards. If I take the integral of a constant, then I get x plus c. Don't forget your plus c. And then think about that. Whatever, if I were taking the derivative of this, it would be whatever was in front here, right? So that's how I get that. If I take the integral of a constant times a function, it's the same as putting the k outside and then just taking the integral of the function, whatever that happens to be. This will make a lot more sense as we do them, so don't start to hyperventilate yet. If I take the integral of a sum, it's equivalent to separating them. So it would look like this. And that's good when I have multiple pieces. If I take the integral of x to the